Everyone, welcome back. So let's finish up the second half of chapter 5 now by looking at frames. So first off, what is a frame? When is it called a frame? We had trusses before. What's this? Well, when forces are applied at more than 2 points along the length of the member, and when the forces are not collinear with the axis of the member is in bending. Okay, so before we had this, 2 forces into the member, no bending. Right here, we're going to have bending. So this is not good. This is a multiple force member. So if we have something that has, like a truss that has a multiple force member, it's no longer a truss, it's a frame. Now these are more difficult to solve at times, so it's good to have a procedure. Now I'm going to show you this procedure, then I'm going to show you an example that has a frame. We're not going to solve the example in this video though, that'll be a separate video, which you can watch later if you wish. I just want to give you an idea of how to solve the problems first. Okay, so first, like always, support reactions. Get rid of those pins, get rid of those rollers, turn them into support forces. Do what you can and see if you can solve them all. If you can't solve them all, then get as many as you can and continue to the next step. Now you want to isolate each member as a free body. Means you actually take the whole beam apart and you say, okay, now I'm not looking at the joints, I'm not looking at the sections, I'm just saying this member itself has to be in equilibrium. And so it might have a force right here, might have 2 forces like this, and you would have to solve for those. Now for each member, you get 3 equations of equilibrium because they have size. So 3 equations, 3 unknowns, and from this you're going to slowly start building it up because each one is connected, and so the forces from one will likely connect another. So when you solve for the reaction force right here for this one, well, it's also the same as the reaction force right here for the other one, though you would draw in opposite directions. And you keep on moving through. If you can't solve everything at one member, you go to an adjacent member, and you keep on carrying it until finally you'll have enough equations and enough unknowns that you can solve. And then if you're not certain, if you think you might have made a mistake, go ahead and check some of the forces in the vertical, horizontal, and so we'll type it right here, it should be some of the moments. Now, let's look at a frame real here. We're not going to solve this, but we're going to talk about why it's a frame. So first off, this right here is a 2-force member. It's attached at 2 points, there's no forces along the length. However, the other 2 are not 2-force members. We have this one beam right here, which is held in place by the little slot, and it's got a force applied 2 points along its length and pointed in. So that's 4 forces, that's a multi-force member. So right here, 1 force, 2 force, and then there's a 3rd force right here, also a multi-force member. So this turns into a frame. We can't use just method of joints, we can't use just method of sections, and so it's going to be better to look at each member individually. So we won't solve this now, I'll also put this in a separate video, you can check out the example videos to find it. But I hope this video helped you at least get a start for how we're going to solve this. And if you still need more help, which I likely will, go check out the example videos too. So thanks for listening, and I'll see you all next time. Bye-bye.